topic, the transient response of RC circuit. Last we have seen the transient response of RL circuit. Now the RC circuit. Consider the circuit consists of the resistance and capacitance connected with the DC voltage source. The circuit shown in the PDF document. When the switch is closed at t is equal to 0, we can find the transient response of RC circuit. And now applying the KVL similar to RL circuit, so VR is equal to V suffix R in plus V suffix C. Substitute the VR value and VC value. So here the voltage across capacitance is represented as 1 by C integral of I into dt. So I either using I or I of t. Therefore V is equal to I into R plus 1 by C integral of I into dt. Next, the above equation, differential equation solved by Laplace transform. So taking Laplace transform on both sides, so we get V divided by S is equal to IFS into R plus 1 by C into IFS divided by S. For Laplace transform, for constant value 1 is equal to 1 by S, and then I or I of t is equal to IFS. Similarly, the integral of I of t into dt represented in S domain is IFS divided by S. Therefore V by S is equal to I of S into R plus 1 divided by C into S. Nothing but taking I of S in outside. So we get the above equation. So finally we need I of S. So I of S is equal to V by S into R plus 1 by C into S. Therefore I of S is equal to V divided by RS plus 1 by C. Finally, IFS is equal to V divided by R into S plus 1 by C into R. Now again the S domain is converted into the time domain. So take inverse Laplace transform on both sides. So L inverse of IFS is equal to V divided by R, L inverse of 1 by S plus 1 by C. So finally I of t is equal to V divided by R into e power minus 1 by R into C into t. Now apply the t is equal to 0 in above equation. So I of 0 is equal to V by R into e power 0. Therefore I or I of 0 is equal to V by R. Now substitute the t is equal to infinite. Therefore I of infinite is equal to V by R e power infinite. The e power infinite value is 0. Therefore I of infinite is equal to 0. Now the transient response of RC's source, take time in x-axis or I or I of in y-axis. For condition t is equal to 0 means the value is V by R. At the same time, suppose t is equal to infinite means the value reaches to 0. So this shows in the graph. Next, similar to RL, here find the time constant for RC circuit. So tau is equal to t is equal to substitute R into C. Therefore, I or I of t is equal to V by R e power, replace t as R into C. Therefore e power minus R C divided by RC. Therefore above equation becomes that is equal to V by R e power minus 1. The e power minus 1 value is 0.368. Therefore I of t is equal to V by R into 0.368. That means I of t is equal to 36.8% of steady state or the initial value. So the time constant for RC circuit is defined as the time constant of RC circuit is defined as the time during which the current reaches 36.8% of its initial value. So initially the value is maximum. Now defining the time constant, some value means the values reaches the minimum value. So now going to find the voltage across resistance, that is V suffix capital R, that is equal to I into R. Now substituting in the value of I. So I value V by R into e power minus 1 by R into C into T, then into R. Therefore V suffix R is equal to V into e power minus 1 divided by R into C into T. The unit is voltage. Next, going to find the voltage across capacitance. So the represented as V sub is capital C, that is equal to 1 by C integral of I into dt. Now substitute the I value. The above equation becomes V sub C is equal to 1 by C integral of V divided by R into e power minus 1 divided by RC into T into dt. So integrate the above equation we get. So that is equal to V minus V divided by that is equal to 1 by C into V into R into e power minus 1 divided by RC into T divided by minus 1 by R into C, the limit 0 to T. So minus 1 by R into C is a constant, so take outside. So minus V divided by R into C into RC into e power minus T divided by RC, the limit 0 to T. The RC cancel each other, so the equation becomes that is equal to minus V into e power minus, substitute the T and 0 value. So e power minus T divided by RC minus e power 0. So therefore e power 0 value is 1. The above equation becomes V sub C is equal to minus V into e power minus T divided by RC minus 1. The unit is volt. So this is the derivation of transient response of RC circuit. Next, going to see the problem related to the RC circuit. Problem: a series RC circuit of a resistance of 10 ohm and capacitance of 0.1 farad, as shown in figure. A constant voltage of 20 volt apply in the circuit at t is equal to 0. Applying the current equation and also determine voltage across resistors and voltage across capacitors. So this is a given circuit. Now applying the KVL, so V is equal to V suffix R in plus V suffix C. Substitute the VR value and VC value, so we get V is equal to I into R plus 1 by C integral of I into dt. Substitute the V value, R value and the C value. So 20 is equal to I into 10 plus 1 divided by 0.1 integral of I into dt. Now taking the Laplace transform. Now that means convert the time domain is into S domain. In 20 it is a constant, so 20 divided by S plus I convert to I of S, so I of S into 10 plus 1 divided by 0.1 integral of I of t, that is equal to I of S divided by S. Therefore 20 divided by S plus, that is equal to I of S, take outside, so I of S into 10 plus 1 divided by 0.1 into S. Therefore we need I of S value alone, so I of S equal to 20 divided by S into 10 plus 1 divided by 0.1 into S. Therefore I of S is equal to 20 divided by 10 into S plus 1 divided by 0.1. Therefore I of S is equal to 20 divided by 10 into S plus 1. So this is our I of S equation. Now again the S domain is converted into the time domain. So take inverse Laplace transform on both sides. Therefore I of t is equal to 20 divided by 10, then 1 divided by S plus 1 is written as e power minus 1 divided by 10 into 0.1 t. Therefore finally I of t is equal to 2 into e power minus t. The unit of current is A, that is ampere. Now we are going to find the voltage across resistance value. So V is equal to I into R. Substitute the I value and R value. So I value 2 into e power minus t into R value 10. Therefore voltage across resistance equal to 20 into e power minus t. Unit is volt. Next going to find the voltage drop across the capacitance, that is V suffix C. We know the equation V is equal to VR plus VC. From that we need VC alone, so VC equal to V minus V suffix R. Now substitute the V value and V suffix R value. So V value 20 and V suffix R value 20 into e power minus t. So finally we get 20 is a common term, so V suffix C is equal to 20 into 1 minus e power minus t into the unit is volt. That's all.